Hey everyone, this is Carolyn.
This is Hannah.
And Mercedes.
And today we'll be teaching you about Diels Alder reactions. So how do we know it's going to be a Diels Alder reaction? Well, first of all, they're always initiated by heat. And you can normally tell this is when you have the reaction arrow with a little triangle under it to represent the flames. Another common trait is that the reaction forms a six-membered ring. The most important part of a Diels Alder reaction is the mechanism itself. So if you have a molecule like this with two alkenes and another alkene over here, all three pi bonds break and you form two sigma bonds and one pi bond. That's important because with the sigma bonds forming, you get a more stable structure. Now all of this happens in one step. It's a concerted reaction, so it's rather quick. Two specific molecules react in a Diels Alder reaction. The first one is called a diene. Now there are two conformations of diene. The S-cis, which looks a bit like this, and the S-trans, which looks like this. To react in a Diels Alder reaction, the diene must be in the S-cis conformation. It can start off in the S-trans, but it must first rotate into the S-cis conformation before it can react. The other type of molecule in these reactions is called the dienophile. Usually you can recognize it as a regular old alkene with whatever group's coming off of it. The mechanism that occurs when the dienophile reacts with the diene over here is that the pi bonds break and the electrons move in a sort of circular pattern. What's nice is that it's all a concerted reaction, so they all happen at once. Sometimes stereochemistry comes into play in Diels Alder reactions. In this first example here, the dienophile is in the Z alkene formation with both groups on the same side. While we'll go into this more later in the presentation, what happens when this reacts is there is stereochemistry with both groups coming out or going in. The opposite occurs in the second reaction here, where we have an E alkene at the dienophile. So when it reacts and forms a six-membered ring, we'll have opposite stereochemistry with one group coming out and one going in.
The first reaction we're going to do is a Diels Alder reaction with anti-stereochemistry. A pair of electrons from the pi bond reacts with the dienophile to form a sigma bond, which pushes the electrons from the dienophile to the other end of the diene, forming another sigma bond, which will push these electrons between the two alkenes, forming a pi bond. Since this is an E alkene, one of the products will have one up and one down. The other product, however, will have one down and one up. This is called a racemic mixture of enantiomers, which are chiral molecules that are mirror images of one another, or they can be opposite one another like the products shown here.
Alright, for our next example, we're going to be doing a Diels Alder reaction with Syn-stereochemistry. This molecule over here is a diene, and this one right here is a dienophile. This goofy little structure right here is actually a five-membered ring, but this is showing the 3D structure as it gives a better view of the molecule. Cyclopentadiene is always going to be in the S-cis formation, therefore it will always be shaped just like this, hence no changes have to occur for it to react. As heat is added to the reaction, this electron moves here, this electron moves over there, and this one moves all the way over here. Now remember that all these steps happen at the same time because it is a concerted reaction. This means it happens in one step. So our end product would look like this. Notice how the end product has Syn-stereochemistry. This means that the bonds are sticking out towards us, meaning solid wedges, or they could be sticking inwards, having the dashed lines. Either way, these both mean the same thing.